Okay, now today discussing about the mechanical properties of fluids.
Okay, sir.
Okay, yeah, this lesson only for our intermediate weight is 2 marks, 2 plus 2,
Okay, sir.
2 plus 2, 2 marks, 2 is given. Now, what is the first question? Like only follow me.
Okay.
Define
Average
average.
pressure.
Hmm,
Mention its unit and dimensional formula. Is it a scalar or a vector?
like average pressure means generally pressure means force by
Force by
area.
area.
Now the average pressure is nothing but
Normal
normal force
force acting per
acting.
unit area is called average pressure.
Yes, average pressure is equal to force by
Force by
area.
area.
It's units of like force
Newton,
units.
Newton per meter square.
Yes, or Pascal.
Pascal.
So the dimensional formula of average pressure is nothing but
ml minus 1, T minus 2.
it is a scalar.
Scalar.
Yes, once again, what is the question? Very important for 4 marks in fluids. So next, define average pressure,
Mhm.
mention its units and dimensional formula.
Hmm.
Yeah. So normal force acting for unit
Per
area is
unit
called
area. Average pressure.
the average pressure is equal to F by A.
Force by area.
Newtons per meter square, it is units.
Hmm.
Yes. Next question mean
Define
define.
viscosity. What
Hmm,
are its units and dimensions?
yes. Viscosity. General. What is the resistance means? Any idea?
Yes, sir. Opposing force.
In the same way, here also viscosity means the property of the fluid which oppose the relative motion between different layers is called viscosity.
Hmm.
Okay, once again repeated.
The
Viscosity.
proper.
What is the definition of viscosity? One units and dimension formula.
Hmm.
Okay. What is the viscosity?
The property of the fluid which opposes the relative motion between different layers is called viscosity.
What is the units of viscosity?
Uh,
Poisson
Poisson.
or po- um,
Pass.
next into the Pascal seconds.
Hmm.
Dimension formula.
ml minus 1, T minus 1.
Yes. Define viscosity. What are the units and dimensions?
Dimensions.
Yeah. Next one.
Terminal velocity is more if surface area of the body is small. Give reasons in support of your answer.
Terminal velocity general formula Vt is equal to 2 by 9 r square sigma rho
Rho
minus
minus
sigma
sigma into G by
into g by eta.
N. Eta.
Now, here 2 by 9 is constant, like rho and sigma, g and n is totally constant.
Constant.
Now, Vt is directly proportional to r square.
R square.
Yeah, area. Why? Because the terminal velocity of the surface area, A is equal to 4 pi r
By
square.
R square.
So, A is directly proportional to r square.
Hmm.
So, Vt is directly proportional to A. Why?
Hmm.
Because A is directly proportional to r square,
R
replaced
square
with r
meter
square is equal to A.
R
Yes.
is
So, the terminal velocity is more
if
if
surface area is more.
more. Once again, what is the question? Terminal
Terminal
velocity.
velocity is more if surface area of the body is more. Give reasons in support of your answer.
Yes. So, Vt is directly
The
proportional to r square. Why
R square.
Vt is general formula?
2 by 9 R square into rho minus sigma into G by eta.
Okay, so ultimately Vt is directly proportional to A
Yeah.
area. So the terminal velocity is more if
If surface
area
area
is
is more.
more. Next question. What is the question?
When water flows through a pipe, which of the layers moves faster and slowest?
Yes, simply by using of water to wall, like central layers move faster. Yes or no?
Yes, sir.
Why? Because generally the pipe is like this is the central layer. This is the edges. So the
Yes.
central layer is move faster compared to edge layers. So the central layer move faster.
Faster.
And again,
Layer of the liquid in contact with the walls of the pipes move slower.
slower. So central layer is fast, walls of the layer is slower.
Slow.
Okay, Nana?
Okay, sir.
Next, why are drops and bubbles spherical?
Yes, sir.
Due to,
Surface tension.
yes, very important question. Simple word, due to surface tension. And
For the given volume, surface area of the sphere is minimum. The raindrops tend to minimize their surface area due to the surface tension.
yes, hence
Drops and bubbles are spherical.
spherical. Simple word. దీంట్లో ఇంకా కొంతమంది స్టూడెంట్స్ వన్ వర్డ్ రాస్తారు డ్యూ టు సర్ఫేస్ టెన్షన్
Tension.
టు ఆక్యుపై ది మినిమం సర్ఫేస్ ఏరియా. That's why the bubbles are spherical.
Spherical in shape.
Very important next question. Given an expression for the excess pressure in the liquid drops. So the liquid drops excess pressure is nothing but only one sphere, like this is like. So P is equal to 2T by R. Here what is P?
Excess pressure.
What is T?
Surface tension.
What is R?
Radius.
So here only 3 questions is very important, but answer may be same, but question is different. This question is indicated by liquid draft. This is nothing but
Liquid drops. P equal to
excess pressure of liquid draft. In the same answer, but question difference. The given expression for the excess pressure in air bubble inside the
liquid.
So here underline air bubble inside the liquid. What is the excess pressure? P is equal to
2T by R.
Same here also 2T by R. Here also 2T by R.
2T by R.
But this is a liquid draft. This is the
Air
bubble.
bubble inside the liquid.
Some students are confused. So both questions are same. Answer is same. The question is simply one is liquid draft, another one is air bubble.
Air bubble.
Yes. Next one is given an expression for the excess pressure of soap bubble. Soap bubble means inside one surface, outside one surface. Two free surfaces. మనం ఎప్పుడన్నా బట్టలు వాష్ చేస్తున్నప్పుడు ఇట్లా సోప్స్ బబుల్స్ వస్తాయి చూడనా, అప్పుడు దాని తప్పు అంటే సౌండ్ వస్తుంది. అంటే ఇన్సైడ్ ఫ్రీ సర్ఫేస్, అవుట్ సైడ్ ఆల్సో ఫ్రీ సర్ఫేస్. సో ద సోప్ బబుల్. What is the excess pressure soap bubble?
P equals to 4T by R.
What is P?
Excess pressure.
What is T?
Surface tension.
What is R?
Radius.
Yes. So soap bubble is a simple word. Soap bubble is 4T by R. Air bubble and liquid drop is R 2T by R. Very good. Next question.
What is angle of contact?
Simply 1 minute. Generally this is like a glass. So one dipped the like a mercury at like this one. So this is a fill the water. This is one area of contact. This is so simple word. The angle of contact, the angle between the tangent draw to the liquid. Tangent draws the liquid and this one the tangent liquid of liquid. At the point of contact, solid surface. Ante ee solid surface angle, liquid surface tangent angle inside the liquid. This is angle of contact. So angle of contact means
the angle between tangent drawn to the liquid surface at the point of contact and solid surface inside the liquid.
Inside the liquid is called
angle of contact.
Now pure water and glass, angle of contact theta is equal to
0 degrees.
And mercury with glass
for 140 degrees.
140. Very important. Once again, what is angle of contact?
the angle between tangent drawn to the liquid surface at the point of contact and solid surface inside the liquid is called
Is
angle
called
of contact.
pure water and glass,
Theta is equal to 0 degrees,
mercury glass.
140 degrees.
Yes. Next one. Mention any two examples that obeys Bernoulli's theorem. It justified. Simple word. What is the Bernoulli's theorem examples? Number of examples. One is,
Venturimeter,
second one is,
Torsell's theorem,
third one is,
aerofoil,
next one.
spinning ball in motion.
Yes, the pressure is low at the large velocity. That pressure low, velocity is high. Like,
Hi.
so examples of Bernoulli's principle. Next, what is Magnus effect?
The
The
difference
difference.
in lateral pressure which causes a spinning ball to take a curved path which is convex towards the greater pressure side is called Magnus effect.
Like it is a ball. So the ball inside and outside. So top of the simple word, the pressure difference is nothing but a Magnus effect. So the difference in the lateral pressure which occurs
a spinning ball to take a curved path which is convex towards the greater pressure.
Simply ball ఇలా rotate చేస్తున్నా curved path rotate చేస్తే definitely higher and lower different pressures is available. This effect is known as Magnus effect. Next one.
What is the principle behind the curvature of an automobile?
కార్బెటర్ ఐడియా ఉందా నాన్న?
No, sir.
ఇప్పుడు మనం బైక్స్ కు పెట్రోల్ ఆన్ ఆఫ్ చేసేది చిన్న ఇక్కడ బౌల్ లాగా ఉంటుంది, ఆన్ ఆఫ్ చేస్తాం ఇట్లా పెట్రోల్ ఆన్ ఆఫ్, అది దాన్ని కార్బెటర్ అంటారు. సో ద కార్బెటర్ వర్క్ ఇన్ ది ప్రిన్సిపల్ ఆఫ్ Bernoulli's principle. Tell me, carburetor has a
venturi channel through which air flows with a large speed. The pressure is then lowered at the narrow neck and the petrol is set up in the chamber to provide the correct mixture of air to fuel necessary for combustion.
అంటే ఇట్ ఈస్ లైక్ యాజ్ ఏ మనం స్ప్రే బాటిల్ యూజ్ చేస్తాం కదా, ఎట్లా వస్తున్నది ప్రిన్సిపల్ వచ్చేస్తుంది కదా, అలానే అంటే ప్యూర్ పెట్రోల్ కాకుండా దానికి విత్ కాంబినేషన్ ఆఫ్ ఎయిర్ with narrow neck. One second, read what the carburetor has.
The carburetor has a venturi channel through which air flows with a large speed. The pressure is then lowered at the narrow neck and the petrol is set up in a chamber to provide the correct mixture of air to fuel necessary for combustion.
Yes. Next, last question. Simply, what is the question?
What are waterproofing agents and water wetting agents? What do they do?
Yes. So waterproofing agents is nothing but what happened to water wetting. Waterproofing is nothing but by using of sweaters. Water wetting is nothing, sponge, towels like. So tell me, waterproofing agents means?
The materials which increase the angle of contact are called waterproofing agents.
Angle of contact is increasing. That is nothing but waterproofing agents. When they are added
when these are added to liquid do not penetrate the cloth well. They are used in the preparation of raincoats.
Yes. Okay, na? Okay. Next one.
Water wetting agents. The materials which decrease the angle of contact are called water wetting agents. When they are added to liquid, they penetrate well into the cloth and useful for effective cleaning and drying.
Yes. Simply, this is nothing but angle of contact decrease. This is nothing but angle of contact increase. Yes. Okay, Nana. These are the total 2 marks in our fluids, only for IP orientation.
Okay.
Okay, right? Next to thermal properties of matter. Open your material.
Okay.
Four marks questions. Thermal properties of matter, 4 marks questions.
Okay.
Open.
1 minute.
Okay. It is 12th lesson.
Yes, sir.
Yeah. And now the first question is Celsius Fahrenheit. First question. See once. Same question. Yeah. Read once question.
Explain Celsius and Fahrenheit scales of temperature. Obtain the relation between Celsius and Fahrenheit scales of temperature.
Yes. So in our heat pot starting lesson, thermal properties of matter, discussing about the types of scales. Scales means Celsius scale, Fahrenheit scale, Kelvin scale, Ramming scale, Rankine scale, like that. But our IP orientation only 2 scales. One is Celsius scale, another one is
Fahrenheit scale.
yes. You know about the Celsius scale. On the scale, lower fixed point is
0 degrees.
upper fixed point is
100 degrees.
number of intervals.
100.
The fundamental intervals divided into each is nothing but
100
equal.
parts.
Yes. Each part represented
1 degree Celsius.
yes. Simple. Lower fixed point is 0. Upper fixed point is 100, and the number of divisions 100,
100.
and each division represented 1 degree.
1 degree Celsius.
In the same way, Fahrenheit scale. What is the Fahrenheit scale?
On this scale, lower fixed value is 32 degrees and upper fixed value is 212 degrees Fahrenheit.
Yes. The fundamental unit intervals 180.
180.
Upper minus like.
180 equal parts.
Yes. So each part represented
1 degree Fahrenheit.
Like a diagram. This is upper, this is lower. Celsius 0 degree, 100 degree. Like Fahrenheit scale, lower is 32, 100 is upper is 212.
212.
The relation between these two.
Yes.
So scale and any scale reading minus lower fixed point by
upper fixed point minus lower fixed point equals to constant.
Now discussing about the two scales. One is Celsius, another one is Fahrenheit. So C minus 0 by 100
minus 0 is equals to F minus 32 by 212 minus 32.
Yes. So C minus 0 is C by 100
equals to F minus 32 by 180. Or C by 5 is equals to F minus 32 by 9.
Yes. It is the first question. Any doubt for first question? What is the first question?
Explain Celsius and Fahrenheit scales of temperature. Obtain the relation between Celsius and Fahrenheit scales of temperature.
Yes. Now the second question is?
Second question.
Same.
Two identical rectangular strips, one of copper and the other of steel, are riveted together to form a compound ball. What will happen on heating?
First of all, what is bimetallic strips? Simply, for steel, one is copper. Steel, copper. Copper, steel. Like so, bimetallic strips means two similar strips of copper. One is another one is steel or riveted side by side as the combined strips is called
bimetallic strip.
Once again, what is bimetallic strips?
Two similar strips of copper and steel are riveted side by side as a compound strip called bimetallic strip.
Yes. Now here, first diagram is indicated by ordinary temperature, on heating and higher temperature, and higher, lower, very lower cooling. Simply, it is straight at the ordinary temperature. Yes or no? There is no change of ordinary temperature. What happened to on heating? What happened to on cooling? What happened to on heating?
When bimetallic strip is heated, copper expands more than steel, so it bends with copper on convex side.
Yes, observe.
Yes, sir.
Copper is more bend
Mm.
compared to steel.
Steel.
Yes. Once again, what is cooling?
When bimetallic strip is cooled, copper contracts more than steel, so it bends with copper on concave side.
It is concave side. It is convex. Observe the diagram.
Yes,
This is concave. Yes. So this is the general temperature. This is on heating. This is on cooling.
Cooling.
So the copper is more like convex side. In the same way, more cooling is nothing but the copper is which
On
side?
concave side.
Concave side. Yes. Now the third question is, what is the third question?
Pendulum clocks generally go fast in winter and slow in summer. Why?
Wait, very easy. At a time, very important. You know, time period of pendulum clock T is equal to,
2 pi into under root L by G.
yes, what is T here?
Time period.
What is L?
Length of the pendulum.
Yes, simple. Here two. One is summer, another one is winter. What happened to winter?
In winter, temperature decreases, so L
So
decreases and T decreases.
simply like observe the any houses wall clock like this one. It is like rotated. These lengths sometimes increase small variation until some students are observes are how to decrease and small variation. So in winter, what happened?
Temperature decreases, so length of the pendulum decreases and time period decreases.
Yes. So what happened? It makes,
More number of oscillations than required per day.
yes. Hence,
Clock goes fast.
అంటే లైక్ స్మాల్ ఉంటుంది కదా, ఫటాఫట రొటేట్ అవుతుంది, స్పీడ్ గా రొటేట్ చేస్తుంది. వాట్ హ్యాపెన్ టు ఇన్ సమ్మర్?
In summer, temperature increases, so length increases and the time period increases.
What happened?
It makes less number of oscillations than required per day, hence clock goes slow.
Yes, simply. So length is increased. If time taken is
Time day increase.
So the hence clock go
slow.
Simple, very important. At a time, very easy. In summer, what happened? In winter, what happened? It is depends upon like T is directly proportional to root L. That means L is increased, definitely time period is also increased. L will be decreased, definitely time period is also decreased. Why? Because T is a time period, L is the length of the pendulum. Next, which question?
In what way?
In what way?
Anomalous behavior of water advantages to aquatic animals.
Simple word. Anomalous expansion of water. Generally, any liquids expand from increase to 0 to 100 degrees temperature. But here, the water
contracts on heating from 0 degrees to 4 degrees and expands from 4 degrees to 100 degrees. This behavior of water is called anomalous expansion of water.
This is a definition of anomalous expansion of water. Now, sometimes I will give to some more information. So simply, density is nothing but mass by volume. So density increases, the volume will be decreases. So density is increasing maximum for 4 degrees. Yes or no?
Yes, sir.
So what is the use of this anomalous expansion of water in aquatic animals? Now the first one.
In cold countries, in winter, atmospheric temperature decreases.
So what happened?
In winter, lake cools. The cooled water at the surface sinks to the bottom because of its greater density.
Next.
This continues until the whole water gets cooled to 4 degrees Celsius.
Observe, this is 0 degree, this is 1 degree, 2 degree, 3 degree, 4. Up to 0 to 4 degrees, definitely contract. Contract means it's like a ice pack. After 4 to 100 degrees, it is expand like it's a water.
Yes.
So the continue until the whole water gets cooled up to
4
4
degrees.
degrees. Next.
When the top layers cool further, their temperature fall below 4 degrees.
Yes.
It expands, becomes lighter, and remains at the top. With further cooling, top layers form ice at the top.
Top of
Ice
this is like
ice.
a ice. This is like a ice.
This.
Hmm.
Ice is bad conductor of heat, so the lower layers are protected against freezing by the layers of ice.
Yes, so
This
the
results in
resultant.
water remaining at the bottom at 4 degrees Celsius, so that aquatic animals survive in those layers of water.
Yeah, simple word. After animals like fishes, different aquatic animals is very small moving in this water. Okay.
Okay.
Any doubt for this question?
No, sir.
Now, very important question. Fifth question. What is the fifth question?
Explain conduction, convection, and radiation with examples.
Very easy. At a time, very important. Simply conduction, convention, radiation.
Radiation.
What is conduction?
The process of transmission of heat from one place to other without actual movement of the particles is called conduction.
Simply like by using of a rod, heat this side, definitely heat is followed this side.
Yes, sir.
So without actual, very important point is here, without actual momentum of the
particles.
yes. Once again, the process of transmission of heat
Transmission
from
of heat from one place to other without actual movement of particles is called conduction.
yeah. Examples.
Solids are heated by the process of conduction.
Very good. Next question. The next point.
Convection.
The heading is convention.
The process of transmission of heat from one place to other by actual movement of the particles is called convection.
Yes. Examples. So here using it momentum is actual momentum. For example, like a bowl to take a water, definitely heat, definitely the molecules are in upward direction.
Yes, sir.
Observe.
Yes, sir.
Yes. What is examples?
Liquids and gases are heated by the process of convection.
Yes. Once again, the process
of transmission of heat from one place to other by the actual movement of particles is called convection.
Next one.
Radiation.
Hmm.
The process of transmission of heat from one place to other without any intervening medium is called radiation.
Without any medium, like example.
We receive heat from the sun by the process of radiation.
Very easy. Once again, read.
The process of transmission of heat from one place to other without any intervening medium is called radiation.
Example.
We receive heat from the sun by the process of radiation.
Yes. Last question. This is nothing but additional question. Sometimes given number of times. What is question?
Explain the point of water. Write a short note on the
triple point of water. Yes. You know what is triple point?
The temperature and pressure at which the three states of matter coexist is called triple point.
You know, three states of matter is nothing but what is the meaning of three states? Solids, liquids,
and gases.
Yes, these are nothing but three states of matter. Coexist. It is called triple point of
water.
So now triple point of water is maintained at temperature is
273.16 Kelvin at 4.58 mm of Hg.
You know, this one is like a centigrades, 0.01 degrees centigrades at atmosphere 80 is 0.006
atmosphere.
Yeah, this is a phase diagram for triple point of water. Along the x-axis temperature, along the y-axis pressure. Yeah, O is the main point,
triple
like
point.
a meet at point. Yeah, like here OA is nothing but fusion curve or ice line, and OB is nothing but
steam line or
vaporization. Now OC is nothing but
sublimation curve or Hoarfrost curve.
Okay. diagram explanation. What is first one? OA, OB, OC is represented the
fusion curve, vaporization curve, sublimation curve, respectively. For water, these are called ice line, steam line, or force line.
Yes. What is ice line?
The curve
Like this
OA
is
is
ice.
the curve OA is called ice line. Along the curve, the solid and liquid are in equilibrium.
Yes, here main important. Solids and liquids are in equilibrium. It has a negative slope. Like this is a negative slope. Next.
Melting point decreases with increase of pressure.
So definitely pressure and temperature is
inversely proportional.
Yes. So next to streamline.
Streamline. The curve OB is called streamline. Along the curve, the
OB is the streamline.
Along the curve, the water and steam are in equilibrium.
Yes. It has positive, like
positive slope.
It's going to upward.
Positive slope. Boiling point increases with increase of pressure.
Yes. Next one.
The curve OC is called Holt-Frost line.
Like this one.
Along the curve, steam and solid are in equilibrium. It has a positive slope. Sublimation point increases with increase of pressure.
Yes. At a point O is called?
These three lines meet at point O is called triple point.
Yes. So, today class, thermal properties of matter, all 4 marks and fluids 2 marks. This session. Okay? Okay. Tomorrow, you write the exam? One model paper also.
Yes, sir.
Read very, very clear and any doubt ask me.
Okay, sir.
Thank you. I'll leave.
Thank you, sir.